Hello friends, very good morning to all of you. So today we are going to discuss PF51, that is Cryptographic Protection of Tokens, JOS, that is JSON Object Signing and Encryption. So we'll just try to understand how we can protect the token using cryptographically method. So yeah, let's begin and we can discuss. In this session we'll talk about cryptographic protection of tokens, that is JSON objects like signing and encryption. So we'll just talk on this, but before that, like, let me just show you. Like, I just shown you that in my previous sessions also. I'm just putting all this presentation in my repository, GitHub repository. So you need to go to, like, I'll just put a link also in description. So I have just created a repository with the name PF files, and in that I'm just putting this, like, for now I'm just presenting cryptographic protection of tokens, right? So you can just click here and you can able to just download this file, the presentation thing. So in similar way we have for others also, right? Just previous we just covered like why OAuth2 is not an authentication protocol. So yeah, you can just download this and yeah, just have a look. Cryptographic protection of tokens, yes, and in this session we'll talk about these two types, like symmetric signatures using HS256 and then asymmetric signature using RS256 algorithm. So I think, yeah, if you remember that we already covered the encryption section, digital signature. So I think you know now, like, what is symmetric encryption, what is asymmetric encryption. Like, if you remember in the SAML communication we talked for example, if we just adding an encryption in our PingFederate for digital signature things, for like basically for the response we are passing, like attribute assertion. So if you want to encrypt the complete part or maybe the any attributes, we can do that using the public key of the application, right? And that's example of asymmetric, where the application have one pair of key, it's just sending the public key to us, and using that public key we are encrypting values and then sending back to the application. Then application can decrypt with the private key application have and then get the information. So that's an asymmetric, and that's mainly used also because, yeah, like it have more because you're not passing any security key, like it's just a public key you are passing. So we can just cover both the things and we can try. So let's go to next slide. So if the authorization server outputs a token that is not protected in any way, and the protected resource trusts what is inside the token without any other checks, then it's a trivial for the client, which receives the token in plain text, to manipulate the content of the token before presenting it to the protected resource. A client could even make up its own token out of whole cloth without ever talking to the authorization server, and a neighbor resource server would simply accept and process it. So that's where the validation PKI is playing a very important role. The validation part. Maybe you are just sending me some token, but how I can verify whether it's correct or not? So they're like this PKI, public key infrastructure, and this like asymmetric symmetric things are playing a role. So we are just trying to, we'll cover both the things here. So since we almost certainly do not want that to happen, we should add some protection to the token. Okay, that's why we want to some add protection. Thankfully for us, there is a whole suite of specifications that tells how to do this. So the JSON object signing and encryption standard, or JOS you can say, the should provide signature, encryption, and even key storage formats using JSON as the base data model. So JSON has one suite of specification. You have some other also which you can use to protect the token, but we have one suite of standard. Like, let's talk about JSON, like object signing and encryption. So there we have these three things. It provides signature, encryption, key storage format, like using JSON as the base data model. So we can just try to now look on the two common cases. It's not only there are two cases only which you can, by using, you can protect the token. You have multiple cases, but these are the two common cases utilized in the industry. So one is symmetric signing and validation using the HMAC signature scheme, and the another is asymmetric signing and validation using the RSA signature scheme. Okay, now we'll just try to understand what is symmetric signature using HS256. It's an algorithm. So by this name symmetric only, you understand that it's a kind of, we have one key and we're just trying to encrypt the values using same key and just passing the same key to the application, to the receiver basically, which they can decrypt using the same key and get the information. So it's a kind like you want to just send some information from one place to another, so you encrypted that with some password, and you just say that same password to the receiver, and that receiver can just decrypt using that password. Maybe you have seen like in the industry, like when you are getting a pay slip uh, by the end of month, if you are working in some company, that file is basically protected, right? So it's an example of symmetric only, because they are just encrypting with some password, and same password you have already, they are just giving you that you can use this password to decrypt, or they are just giving some like kind of date of combination, like date of birth and your name like that, and you can just decrypt using that. So it's a kind of symmetric example. Okay, so in this we are going to sign our token using a shared secret at the authorization server, and then validate that token using the shared secret at the protected resource. That means protected resource, because it's a protected resource who needs to do the validation of the token. So the protected resource can have that secret key, shared secret key, so it can just do the validation. So we just need to put this shared secret key at two places. One at the authorization server, which basically used to sign the token using that same key, and one at the protected resource server, which they can able to verify. Okay. This is a useful approach when the authorization server and the protected resources are tied closely enough to have a long-term shared secret, similar to an API key, but do not have a direct connection of each other to validate each token directly. That's true. First, basically we are going to add a shared secret to our authorization server. So you can just put like this. This is a simple like code part where shared token secret is equal to whatever the shared secret token value you have. You can keep like this. Now we'll use that secret to sign the token. Change the header parameter to indicate that we are using this method, HS256 signature method. So you can just put like var header is equal to type jot JSON web token, and algorithm is HS256. So you just added the header part. Okay. So basically we are including the HS256 signature method. Now just use like JOS library to apply this algorithm using shared secret to the token. Due to a quick and chosen JOS library, we need to pass in the shared secret as a hex string. Other libraries will have different requirements for getting the keys in the right format. So this is one like way by using JOS library. We need to just pass the shared secret as a hex string, and then other libraries maybe have different requirements how they want to just pass the key. The output of the library will be a string that we will use as a token value. Let's go next. So you can just see var access underscore token is equal to jos.jws.jws.sign. Bracket you can put header dot algorithm JSON.string file header JSON.string file payload, and then you have the shared secret shared token secret to string to hex. Basically you just converted that shared value secret value or key value to the string hex, to the hex value basically, right? So you have the header, payload, and signature. So if you remember that, if you just decoded the access token before, or maybe we have covered already in our previous session. So once you decode, you can see there are three values in that. One is header, payload, and signature. So this is the same format, right? We have the access token. So the final JSON web token looks like the following, as you can see in the below. Yeah, this is an example, right? So if you can see here, like maybe you already decoded the access token, you already generated multiple tokens, right? We already tried multiple OAuth based applications. We tried like OIDC scenarios. So we have seen those, but maybe I haven't discussed that because I want to discuss that in this session, because here we are talking about how to protect the token. So in that, like access token, like maybe if you observe like closely, there are three dots there, like okay, which not three, it's basically two, which basically separates three things. And what are the three things? As we can see in the decoded form of the access token, it's header, payload, and signature. That's what I mentioned here. The header and payload remain the same, base 64 URL encoded JSON strings. The signature is placed after the final dot in the JOT format as a base 64 URL encoded set of bytes, making the overall structure. So the above you can see the access token is this, right? But here you can see, if you can just separate using dots. So there are three things here. So first from E to 9 there is one thing, then you can see there is a dot, then from EY to J9 is another, and then another last dot is YA to underscore K. So the first one is header, the middle one is a payload, and the last one is signature. Okay, so this is the format of JSON web token. Now the same shared secret loaded into the protected resource server file, as I told. So there are two places where you need to add this secret, basically load that secret key. One in the authorization where it used to sign, and another in the protected resource which can verify the token. So the protected resource server will validate the signature based on the shared secret. Also, in case of JOS library, first we need the secret to be converted to hex before it can validate the things. That's the requirement in the JOS library, to convert the secret into a hex value. Okay, but yeah, like it's fine. Like it depends, like on different library have different type of requirements. Resource server will only accept the token that have been signed by the secret that it shares with the authorization server. That's true. Okay, so that's about symmetric, where like it's just a like same thing. You have one key, you are just encrypting, like signing that the information with that, and then sending that the key to the receiver, so the receiver can do the validation of the token. It's just a concept of digital signature, if you remember, like, or maybe if you can just watch my session again, like like digital signature section, where we just try to cover how the signing part is happening, how the trust is getting established, all those things, to get more detail. But yeah, that's the same thing we are repeating again, but in terms of the token, access token came, and we are talking in terms of this, but that's the same thing. Now let's talk about asymmetric. It's a kind of same thing, asymmetric signature using RS-256, but here it's what will come, there will be a pair of key PKI, and we can see how the things are working. So in this section, we are once again going to sign the token with a secret key, as we did in the last section. However, this time we are going to use public key cryptography to do it. With a shared secret, both the systems need the same key either to create or validate the signature. With PK, public key cryptography, the authorization server has both a private key and a public key that it can use to generate tokens, whereas the protected resource needs to be able to access only the authorization server's public key to verify the token. It's the same concept, right? A digital signature. If you remember that we discussed sender and receiver, right? Sender will just have the one pair of key, public, private key. It can just send that public key to the receiver, right? And then first what the sender is doing, like in the example what I just covered before, we have some message, right? What I need to send to receiver. So what I'll do, I'll just calculate the unique hash value of that message, and then I'll just encrypt that to get a digital signature, and then I'll just send that digital signature plus the message to the receiver. Now receiver has to using that public key, because receiver has already the public key of the sender, so it can just use that public key to basically it has to do two things, right? So it is having the message and it is having the digital signature, so it will just try to first use the public key to decrypt that message, decrypt the digital signature to get the hash value, and it can just also calculate the hash value of the message and then try to compare if the digital signature the hash value came and the hash value of the original message, if both are matches, then it's fine, otherwise it will not allow. So the same section in the section we discussed already, right? The digital signature concept. So same thing is here, like authorization server will generate a pair of key, public, private. Public it will send to the receiver, that is protected resource server, you can say, which is going to do the validation, and then it can just sign the token and send to. So we can see how it's doing. So we are going to use RS-256 signature method from JOS, which uses the RSA algorithm under the hood, right? First we need to add a public and private to our authorization server. Our key pair is a 2048 bit RSA key, which is the minimum recommended size. That's fine. That's the same bit size we are using while we are generating a self-signed certificate in PingFederate also, right? So we'll create our access token string, which like we did before, except this time we use our private key and the RS-256 asymmetric signing algorithm. So here just put var header is equal to type JSON web token, algorithm is RSA key.al algorithm, and KID is RSA key.KID. Then just put var private key is equal to jos.keyutil.ket key, RSA key, and then finally just create that var access underscore token is equal to jos.jws.jws.sign. In the bracket put header.algorithm, JSON string file header, JSON string file payload, and the private key, header payload signature. The result is the token similar to the previous one, but it is now been signed asymmetrically. That's the difference. The header and payload here again are still base 64 URL encoded JSON, and the signature is a Base 64 URL encoded array of bytes. The signature is much longer now as a result of using the RSA algorithm. Yeah. So we are using RSA SAR-256. So now the signature length will be little longer as compared to the older one where we have the HS256, that's symmetric case. Now we do have to tell the protected resource how to validate the signature of this new JSON web token. So need to add the authorization server public key in the protected resource server file. And then we'll use our library to validate the signature of incoming tokens based on the server's public key. Load up the public key into an object that our library can use and then use that key to validate the token signature. So where public key is equal to jos.keyutil.getKey, and if jos.jws.jws verify end token public key, in the backend you can define header.algorithm. Now this has been set up. The authorization server can choose to include additional information for the protected resource consumption such as scopes or client identifiers. Yeah, that's one thing, like, but yeah, you authorization server can just choose to maybe add any other information like yeah, any scope or maybe any other client identifier you can add. But yeah, this is the way, like so in the asymmetric case it's just like first you need to just make some changes on the authorization server file. That means you are just saying how first you need to create a one pair of key, public private, and then basically you are just using that private key to have create a to basically sign the token, and just sending the public key to the receiver, that is to protected resource server. That basically you are just adding that public key of the authorization server in the protected resource file, server file, so that it can just do the validation of the token. And yeah, along with that validation you can just if once it is set up, then yeah, the authorization server can choose to include additional information like as mentioned here, like so that for whatever the protected resource consumption is there, like scopes or any other client identifier. Okay, so this is the end of the slide. So this is just a example. I think digital signature concept we just revised again about asymmetric, symmetric. But yeah, this is the way how application is doing. Or maybe for example, if you're using that product, right, you're using some PingFederate, Octa, whatever product we're using, maybe right now we're talking about PingFederate. So you can see that we are just choosing there, right, how you're signing the token, you're just putting algorithm, you're putting the key. So yeah, the backend concept is just the same thing, right? So PingFederate is generating that private key and the public key, and yeah, like it's just using the way what we have covered in the previous section of digital signature. In a similar way, it is just signing the token and sending that public key to the protected resource. If protected resource want to do the validation of the access token, and it is not only for the protected resource, right? It can be for the client, because PingFederate is sitting at the authorization server. So we basically created one pair of key, public private, and using that private key we basically sign the token and send that token to with the signing, and basically sign the token with our private key and send that to the client or maybe any application. Now it's a application also needs to do the validation, so it can just do the similar perform, right? It is having the public key of the PingFederate authorization server and along with the message, right? So yeah, so it can just use the concept like of the decryption of that digital signature, and then calculating the hash value of the message, and then yeah, just confirm that yeah, whether it's fine or not, and then yeah, it can just go for the next process. So it's just a digital signature concept, nothing much. But yeah, this is the way like what PingFederate is doing, or maybe any other product is doing in the backend. Okay, so yeah, if you have any questions, please put in the comment section, and let's jump to the next section. In OAuth, I think we just need to cover many other vulnerabilities also. It's not completed. There is, I think we covered, it's just about the token, but there are multiple. You can see in the coming session, and maybe it will be like 20 more session I need to take, where I can just cover like vulnerabilities. So yeah, it will be a little longer, but yeah, let's try to complete that so that you have understanding that yeah, I am using OAuth, I'm using OpenID Connect, but I need to know that where are the vulnerabilities and how I can mitigate those, or what precautionary measures I can take to avoid any issues, right? Okay, yeah, thank you. Let's jump to the next section.